So now we're going to be looking at different mechanical waves and sounds, and we're going to start with traveling waves. And so the basic equation for wave equations we're always going to do is velocity equals wavelength times frequency. So wind gusts create ripples on the ocean that have a wavelength of 5 centimeters and propagate at 2 meters per second. What is the frequency? So the frequency is v over lambda, and that is 2 meters per second divided by 5 centimeters. I got to put it in meters, 0.05 meters. And what is that, like 40 hertz. Okay. How many times a minute does a boat bob up and down on ocean waves that have a wavelength of 40 meters and a propagation speed of 5 meters per second? So V is equal to lambda F. That's always the equation we're going to use. But times per minute is like number of cycles. So we kind of have to think about it based on frequency. What the F means, because I can solve for frequency. It's V over lambda, and it's 5 meters per second divided by a wavelength of 40 meters, and that ends up being 5 divided by 40, which is 0.125. And we call this cycles. It's hertz, but the way you would think of it is in the period is 1 over F. And so this one is hertz, which is cycles per second. So that means in 1 second it goes 1/8 of a cycle, or 1 over F is 1 over 0.125. 125, which is 8 seconds. That means 8 seconds it goes. It repeats, right? That's what the period means. 8 seconds it repeats. So in 1 minute, we kind of question how many times does it go up and down? Well, 1 minute is 60 seconds. So 60 divided by 8 would be how many periods? And that's 7.5 periods. Okay. And so 7.5 times is kind of where you would get there. It's 7.5 periods, because at 64 seconds, it would have gone down 8 times, right? Because 8 times 8 is 64. So, what is the wavelength of the waves you create in a swimming pool if you splash your hand at a rate of 2 hertz? So the frequency is 2 hertz, and the waves propagate at a speed of 0.8 meters per second. So V is equal to lambda F. That's the way you should always try to remember the equation. And then wavelength is V over F. So that's 0.8 meters per second divided by 2 hertz. Hertz is 1 over seconds, and so these seconds cancel, and I get with meters 0.4 meters, which is the unit of wavelength. Radio waves are transmitted through empty space at the speed of light. V, this is the velocity, by the Voyager spacecraft, have a wavelength. So lambda is equal to 0.12, and they say the velocity is equal to 3 times 10 to the 8th. Lambda F, V over lambda. You're sort of doing the same thing. So 3 times 10 to the 8th meters per second divided by 0.12 meters. And that gives me, in hertz, 3e8 divided by 0.2 is, I don't know, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2.5 times 10 to the 9 hertz. And if you don't know, this is 2.5 gigahertz, which is kind of around what your microwave operates at. Quality assurance engineer at a frying pan company is asked to qualify a new line of non-stick coating frying pans. The coating needs to be 1 millimeter thick. So I have a 1 millimeter thick. Let's just draw it like this. One method to test the thickness for the engineer: to pick a percentage of the pans manufactured, strip off the coating, and measure the thickness using a micrometer. This method is destructive testing method. As you can imagine, you can't use a pan anymore. Instead, the engineer decides that for every frying pan will be tested using a non-destructive method. An ultrasonic transducer is used to produce sound waves with a frequency of 25 kilohertz. The sound waves are sent through the coating and reflected back the interface of the coating and the metal pan, and the time is recorded. So we send a wave, it goes down, and it comes back, right? Boop, boop. The wavelength of the ultrasonic waves is 0.076 meters. What should the time recorded be if the coating is the correct dimension? So I can find the velocity of the wave, right? It's equal to lambda F. It's equal to 25 times 10 to the 3, because it's kilohertz, times 0.076 meters. 25e3 times 0.076, 1900 meters per second. Okay, Now, now that's how fast the wave is going to travel. Velocity is distance over time, right? If it's moving at a constant speed. So the time it will take is the distance over the velocity. The distance it travels from there and back is 2 millimeters. Divided by the velocity of 1900 meters per second. And so that's 2e minus 3 divided by 1900. That's 1.05 times 10 to the minus 6 seconds. Or 1.05 microseconds. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.